Okay, let's start. Well, last I think we have seen about concurrency, right? And those are all core Java topics, right? Core Java in the sense related to the Java language itself. Fine. Now we are moving towards something which should help us in enterprise applications. Okay. So let's break it with the topic for RMI. Right? We have one topic called RMI. So what is RMI? Yeah. Okay, it stands for remote method invocation. Okay, what do we understand? What is the impression it gives when it says remote method invocation? The name, what does it suggest?
Like a method A is invoking method B.
A method?
A is invoking method B, something like that.
Methods, any method can invoke any method, but then that word remote, methods are invoked on objects.
Yes.
Okay, methods are invoked on objects. Fine. And then it says uses a word called remote. So what does it suggest? What does the word remote suggest? What's the suggestion there? Yeah.
Something that controls.
Something that?
Controls.
No, no, not about controlling. When we say remote, it means it's not on the same machine. Not on the same machine. When remote, it's a remote place, right? It's a in that sense. That remote is in that sense. Okay. So when it says remote method invocation, yeah. What's the suggestion? Ability to invoke a method on an object which may be on a different machine. Okay, fine. That's a suggestion, right? But actually, it's about how do we develop such objects. It's not that you can invoke a method on any remote object, fine, on any object which is on a remote machine. It's not that way. Okay, this is actually about how do we create objects, how do we develop such an object so that we should be able to invoke a method from a remote place on that object. Okay, it's about how do we develop such objects, right? It's not that, okay, if someone has some object being created, fine, you have developed some class and you have an object on which has been created on a particular machine, you won't be able to invoke a method from any place. It has to be only from that machine, right? That's what we understand, and everything happens within one virtual machine. Okay, so RMI is actually about how do we develop objects. Okay, let's say uh, we have some machine. Fine. Let's consider two different machines. So we have some object on this remote machine. This is my local machine, so that's my remote machine. Okay. So on this remote machine, I have some object. Uh, from here, some application just wants to invoke a method. Then no, you can't do that normally. Okay, it's not just like that. Okay. So for being, so my requirement is, yes, I want to have such an object which allows someone from a remote place to be able to invoke a method there. Fine. This is some client. Okay, I am using the word client here. Okay, client is the one who wants to use the things. Okay, and here is a machine where we have our, this is, let's call our remote machine. Fine. When I say remote here, it may be still be on the same physical machine, same host, but it is a different virtual machine. Fine. Our JVM is, when these are two instances of JVM, maybe on the same machine, on a different machine, that's also fine. Okay, but different JVM. Okay, so yeah, what's the requirement? Oh, we would like to be able to invoke a method on some object over here, right? So what is required here is, for this kind of invocation to work, we understand that interaction can take place only within a machine. Okay, fine. The interaction can take place only within the machine. Okay, so in order to enable this invocation on an object which is on a remote machine, okay, what would be needed is, it's not sufficient to just create a single object like this and then expect that, oh, people will be able to invoke a method there. Okay, what would be needed is some more helper objects are necessary. Fine, we need help of some other objects, okay, which will have their own task, which is well set out what they would be doing. Fine, in order to enable a invocation of a method on an object over here, so this would require developing not only our required target remote object, but also two more helper objects. And there's one model by which you can have two additional helper objects, one helper object on your own machine, client's machine, the one who wants to invoke, and one on the remote machine, fine, where the object on which the method has to be invoked. But these two will have to be such that, yes, they will have to correspond to what is here. Okay, they will have to correspond to the remote object. Okay, so yes, what we have here is, oh, for the one the client who wants to invoke a method on a remote machine, yes, he has one local object, he has to manage a local object, okay, on which he will be able to invoke the method which he wants to invoke here. For the client, it should look as if, oh, this object, for this object, oh, he's saying this object, and he thinks it's that object. Right? There's a local object here, which we know, which is actually known as the stub object. Okay, fine. That's one helper object. There would be a helper object on the machine on this side. That's the skeleton. Okay, fine. And these two would be having a TCP/IP connection. They're assumed to be having connected using the TCP/IP. Okay. So now, yes, what is the exact sequence? What exactly happens? Another point here: the skeleton here knows is a skeleton for a particular object. So this skeleton knows the remote object on which the method needs to be invoked from a remote place. Okay, so the final picture would look like this. If you want to invoke a method, okay, you invoke a method on the stub. So invocation takes place on the stub. Okay. So when a client invokes a method on the stub, what will be done by the stub? There is a protocol between the stub and the skeleton. There's some protocol between the stub and the skeleton. There are some things which will happen. What will the stub do?
We'll try and make a connection to the skeleton.
Okay, it's connected to the skeleton. So on this connection, what should it do?
Pass that object to the skeleton.
It should pass the.
Pass the request or
So fine. What it can do is simply it can say, okay, oh, this is the method which is being invoked. This client here wants to invoke so and so method, and these are the parameter values he has given. Send all the parameters to the skeleton. Stub's responsibility. Send the method name, send the parameter values, and then wait for a response. Fine. Send this information. What the skeleton can then do, or when you receive this information, skeleton has this object, the remote object, and skeleton knows this remote object. So on that remote object, the skeleton can simply invoke that method because the method name is known. It knows, oh, that's a method to be invoked. Fine. And then parameter values also I have received. Let me invoke the method. And it invokes a method. The method here would return some value, or it might throw an exception. Fine. Whatever it does, yeah, what will this skeleton do with that? Skeleton receives the return value. Then
Prepare the response and send to the store account.
what will it do when it gets a return value?
Prepare the response.
Send a response. So what is the response which is sent by the skeleton? The method has completed successfully, and here is the return value. It is sending the return value back to the stub. See what is taking place. What's happening between the stub and the skeleton?
They are maintaining the connection.
Connection is maintained, and then what is being exchanged between them?
Data and
The data,
data is exchanged.
right? Fine. So initially, it is the stub who is sending.
The data.
What is being sent?
Method.
Parameters. Fine. The parameters of the method, right? Okay. So this, what it has to do, it has a TCP/IP connection. It's a serial connection, not serial. So it's a stream-based connection. So can I send anything on the stream?
No, only strings.
Only strings can be sent. Is it so?
Data. Packets.
What kind of things can be sent on a stream? On a stream. Stream here I am referring to because it's a TCP/IP connection. It's what I get is a IO stream. I'm talking about IO stream. So on an IO stream, what can be sent? Can we just send anything? Can I send any object? Yeah, as parameters, I might be sending some primitive values. I might be sending objects. Right? I have objects. Parameters can be objects also, right? Primitive values are fine. Yeah, primitive values should be fine, right? Sending primitive values is not a problem. But can I send any kind of object on a stream? For sending objects on a stream, what is necessary? What kind of objects can I send? Or do we have a stream, IO stream, which can enable us to send objects? I have given sufficient hints which stream I am referring to. Stream.
Object input.
Object streams, yes. So if you have object streams, oh, what's the necessary thing? Can any kind of object be sent on the object stream? If it's an object output stream, can I write any object on that? Yeah, what's the necessary thing? There's something, small thing, which is a basic requirement. What's the method to be used on the object output stream? Write object. Okay, that's what it will be doing. Okay, what's necessary for write object? Can I write any object? No. What's the requirement? It should be serializable. Fine. It should be implementing serializable. But that object network must be serializable, right? Then it can be sent. Clear? Fine. Parameters serializable. Primitives, or they are all serializable, something which can be sent on an, because what you have a stream based connection here, so not any kind of object can be sent. Now this process of converting an object into appropriate form to be sent on a network, okay, this process is known as marshalling. Okay, so what is the stub's role? What does the stub do? It marshals the parameters. When we use the word, it is marshalling the parameter. The term used is marshalling. Yes, internally what's happening behind the scene? Oh, it's using that serialization. Okay. Yeah, but the term used is marshalling. So stub's role, marshal the parameters. What will the skeleton do? Unmarshal the parameters. And we say it is unmarshalling the parameters, then invoking the method, fine, getting the results, getting a return value, and then it marshals the return value. Fine. See, in this protocol, yes, there would be indication that it is successfully completed, and here's the return value. Okay, or if it is failing, it would still be catching all exceptions here. The skeleton here would have to catch all exceptions. Any exception caught, what will it do? Give an indication this is the error, and that's the object which was thrown. So when the exception object is getting back to the stub, and the client who invoked then receives this method. So what's the method implementation on the stub? What's the method implementation on the stub? Receive parameters, whatever parameters have been given, marshal them, and wait for response. Unmarshal, it's unmarshalling the return value and returning it. Fine, that's what it is returning. It is returning what has been received on the by process of unmarshalling of return value.
What do you mean by marshal and unmarshal?
Marshalling is known as sending. Fine, the process of converting objects into a form so that it can be sent. That is what is called as marshalling. So he said he is marshalling. The stub is marshalling parameters. This is unmarshalling. Skeleton is unmarshalling the parameters. Then it invokes the method. It gets a return value. So it marshals the return value. Sending. Fine. That's the marshalling. Okay. It marshals the return value. This one unmarshals it. Okay. Stub is going to unmarshal the return value and then return it. Okay, now something, what is common between this particular object and the object over here, the stub and the remote object. Let's call this as our remote object. So what's common about the remote object and the stub? What's common between them? See, for the client, the stub is like the remote object. He thinks that's a remote object. The client is all the time thinking, oh, that's my remote object. The client is able to invoke the methods. The client is always going to be invoking the methods which are available on the remote object. But where is he invoking? He's invoking it on the stub. So what's common between the stub and the remote object? They share the same set of methods. Oh, we have same set of methods in stub and the remote object. You invoke a method here. That's a method which is actually available on remote object. What is the stub having? What are the methods available on stub? The methods of remote object. Fine. So it looks like a remote object for the client. What is the object on the remote side? It's the same object which is being looked at by the client when it is looking at the stub. Okay.
Some example of
Yeah. And let's see what exactly is useful here. Okay. So we can think of something like this. Basically, what are these methods? Some kind of a functionality available on an object, right? Fine. We have objects. The methods are nothing but the kind of interaction which we can have with the object. Okay. Fine. Methods are for that purpose. Now, what's the role of an interface? What is interface? Interface is also just saying, oh, this is the kind of functionality needed in an object which is of this type. Okay, let's consider a small example like this. Let's say we consider a banking application. Okay, and we might have uh, normally would think of a class, but let's not think about whether it's a class or interface or anything. But yes, I have something called a bank. Okay, having a functionality of open account. Okay, where I should be able to specify the name of the account holder, or I want an account for so and so account holder. Fine. I should be able to specify uh, account holder's name and the opening balance which I want, what type of account, the type of account. Fine. And maybe something like what's the opening balance. Fine. And this would return a account number back to me. Okay, so you get back an account number, maybe a string or a long, whatever. So it's returning an account number to me. When I say open account, yes, it does this and returns a account number back to me. So like this, there'll be something called deposit. If I want to deposit, specify account number and specify the amount to be deposited. Fine. Deposit may not return a value. Fine. We have methods which define a bank. Bank is something which provides me these functionalities. Here, we should think of implementation here. We should think of functionality. Fine, and therefore, we'll put this as an interface. Okay, fine, we go with something called interface. So, bank is nothing but an interface. We can have some implementation of bank, okay, which implements all this functionality. Fine. So, first you start with an interface. Think of an interface called bank. Write an implementation class and let's call that as bank IMPL. That's our implementation class. Fine. This implementation class is nothing but our remote object. Okay. Fine. This is nothing but that's going to be our remote object. And then what is bank? Bank is the interface. It's that common interface. It's nothing but, oh, this stub here is a bank. This remote object here is also a bank. They're both bank. They both have the same set of functionality. Same methods. We want the same methods available at both the places. Okay. This is where you have done your implementation, how it should actually do the job. And that's a place where we have a implementation which is doing the job of marshalling and unmarshalling, enabling me to get all the things done. But the same set of methods. Fine. So here we should go for, we should have bank as an interface. Okay. And then have, so normally you design with interfaces. Fine. You start designing your system in terms of, okay, well, I need so and so functionality. So think of an interface as a set of functionality which I need from an object. Okay, what kind of functionality I need for an object. Now, Fine. Now let's talk about the actual thing, which is nothing but what is the requirement in RMI. Yeah. So in RMI, yes, what we need is it's not just about developing one particular object as a single class file. Okay, it's about developing rather than calling it as simply an object or developing as some kind of a class, which is going to result in an object. Let's call it this as how do we create a remote type. This bank here is nothing but a type which is a remote type. Why we call it as a remote type? Because if it is something is of this type, it allows me to be usable from a remote place, and from a client can invoke it on a remote object. So we would like this functionality to be available remotely. A set of functionality which has been identified, this is what we would like it to be enabled for remote place. Okay, so that's your first starting point. So in RMI, you always start with a interface. Let's look at these steps. How do we develop such an object, right? Which can be invoked from a remote place. So, okay, I'll show some comparisons later. Maybe. So let's start with this, something like this. So how do we start it? Yes, we'll start with first step. First step is identify your methods which you would like for remote invocation. Fine. Identify the methods for remote invocation. Okay. Fine. And then define an interface. So first step would rather be these methods need to be put in an interface. Fine. So define interface. So step one other is define interface. Now a few things about this interface. Okay, define this interface with these methods, and the requirement for this is this interface. Okay, this interface must extend from an interface called remote. We have an interface called remote, which is part of the java.rmi package. We have the java.rmi package where we have the interface called remote. Okay, that's one thing. Another thing is all the methods here. Okay, so one part is we have identified methods, and this interface would be extending from remote. The other requirement which we have, yes, when we identified the methods, we would have identified the exceptions that it will be throwing, right? Now, see one thing. As far as this interface is concerned, the interface is common between the stub and the remote object. Both are going to be implementing this interface. Okay, we are going to be writing an implementation which is going to be for the remote object. There's also going to be an implementation of the same set of methods for the stub. Okay, now when you invoke the method on the stub, we have one additional kind of failure which can happen. There is an additional exception which can happen because of the failure between the stub and the skeleton. We can have some failure taking place between the stub and the skeleton. That protocol which is between the stub and skeleton can fail, and that exception is known as the remote exception. And that exception is nothing but it is our remote exception. So in our interface, the methods, whatever methods we have identified, over and above the exceptions which you might have identified because of your implementation in your remote object. And for example, okay, when I invoke the deposit method, it can throw no such account exception because that account number which you have passed is not a valid account number. Fine. Or maybe you have given a negative value for the amount, so it might also be throwing a negative amount exception. So over and above the exceptions which are already identified, you have to add one more exception to them. So the throws will require, so all the methods would always require in the throws clause to include one more exception, and that exception is our remote exception. Okay, fine. So one requirement defined with these methods, and this interface would extend from remote. Second requirement, all methods have throws for remote exception. Again, remote exception part of java.rmi package. And this is again within the java.rmi package. And that's in java.rmi. So that's your first step. Clear on this? Step one. Okay. Fine. For example, in case of bank, what one would do? Yeah. So it would look like this. You'll have whatever package you may. I'm not showing that. I'm just showing the entry. Relevant thing, something like this. Public interface. So we are defining an interface as an example. Okay. And we're saying that interface is the bank interface. It extends from java.rmi.remote. Okay. Right. And within this, if you look at any method, maybe we have a method called, so I'm not showing all the methods, but some method if you want to take. So we have the method for, let's say, deposit method. So deposit returns void. The method name is deposit. Right? Takes parameters as long, the account number, and another long for the amount to be deposited. But it would need a throws. You have your own throws, maybe no such account exception. But not only no such account exception, it would also have, it should include exception for remote exception is a must. And maybe if you have some additional exceptions, you can add them in the throws. But this is a must, remote exception. Okay. So that's my step one. Step two. Let's proceed. When clear with this step one. Okay. So first is yes, we are having the interface. Right? So that defines yes what should be there. Next, of course, will be about writing your implementation class. Okay. Now, when you write that implementation class, there are a few things. You will write implementation of the method which you have identified. You will be using internally your own data structures. Maybe you might use map or any such structures which may be necessary for managing the various account objects internally. The bank may be having some account objects to be managed, account number wise. So maybe a map. Fine. Fine. Plus whatever additional. So you write your implementation class. Fine. It has its own things. But one more point what we have here is as far as this stub object is concerned, if you look at this object, okay, if you look at the stub object over here, okay, now on the stub object, the client is free to invoke which all methods. What all methods will the client be invoking? He is allowed to invoke which methods? All the methods of the interface. Over and above these methods, some other set of methods are also valid. Which are those methods? What methods can I invoke on any object? What are the methods available to me which I can invoke on any object? Can I invoke the toString method? Allowed or not? That gives you some hint. What all methods are allowed here? Is it just the methods of that interface?
No.
No. We also have the methods of
Inbuilt class.
the object class. Oh, the methods of the object class. Oh, there's so many of them, right? There are 11 of them. We have those methods called wait and notify and all those things also, right? Happening. Yeah. So when someone invokes it here, fine, there might be a typical requirement how these things need to be implemented in case of a remote method. Fine. In case, fine. For this RMI, fine. Okay, these methods need to be implemented in a typical way at this place also. How they should be implemented for the remote object. They are not to be invoked in they're not, the implementation is not the normal way. Fine. Whatever you inherit from the object class, okay, the implementations for the methods like wait and notify, no, they may not turn out to be correct, right? Because we have clients on remote machine also now. And when someone says wait, oh, what is it waiting for? It's waiting for something from remote place, not someone in local place. Right? The way the methods have to be implemented in this remote object, methods of the object class, is not the same. Is not the one which you normally inherit from the object class. Okay, so it's not good to inherit from the object class straight away. Okay, so what we have is we got some class which can be used as a base class for this, so that we can inherit these implementations. Right? So our second step goes like this. Step 2 is, of course, it's about writing the implementation. Okay. Write implementation of our remote object. Write implementation of that interface, right? Of interface. Right? But the requirement is, in order to inherit those implementation special methods, right, especially for the methods of the object class, you should have an implementation. So write implementation of interface. So that's your class. So this will be a class. which extends. Now this is a class which extends from, okay, this extends from is in order to inherit the implementation. So it extends from a class called, we have this class called unicast remote object, okay, which is part of java dot rmi dot server package. So we have the java.rmi dot server package where we have a class called unicast remote object. Right? So you write your implementation class. Right? So example here would be, okay, so we have this class and there's one more requirement within this class itself. Okay, there will be one more requirement in this class. Now, see, whenever we have any class being developed, okay, if it is inheriting from some superclass, okay, the constructor always uses the constructor of superclass. So now the constructor of my implementation class here is going to be using the constructor of superclass. The class here which we have is the unicast remote object. And the constructor of unicast remote object, there's a default constructor. Default means the constructor without any parameters. Okay, and that constructor throws remote exception. The constructor of unicast remote object, which is without parameter, has a throws remote exception. So what we normally have to do here is we have to have a constructor. Okay, so whatever constructor, you may have your requirement for a constructor with or without parameters. So whatever constructor we write, okay, so the other requirement, constructors should have throws remote exception. And throws remote exception in the constructor of our implementation. Fine. So let me give just a small, just a template part for this. For example, okay, what you might do here is, now even a naming convention which is followed is like this. Our interface name is bank, if that's the name. Okay, the implementation class will be called as bank IMPL, bank implementation. Okay, so second step, what you might be developing is something like this. You might have your public class bank IMPL extends. Oh, I forgot one more thing. Yeah, no, I think I mentioned it already. Extends, yes, what will it extend? Unicast remote object. And then it also has implements that remote interface is bank. Okay, and within this, whatever else may be there, you would have some constructor. So maybe you have a public constructor for bank IMPL. Maybe it requires some parameter. You may have without parameter, with parameter. So maybe in this case, the parameter is a string for the name of the bank. Okay, maybe bank name is required to be specified. You might have some other parameters, that doesn't matter. But the thing is, it has a throws remote exception. throws remote exception, and then whatever is required in the constructor might be doing. So that's the kind of thing the other elements will come. And so the necessary thing, your implementation class extends from unicast remote object, implements your interface, and the constructor has throws for remote exception. Fine. And here, okay, fine. So now you got what? You've got your interface, you've got your implementation class. What remains? The helpers, development of the helpers. Helper is nothing but the stub and the skeleton. Right? We need to be developing our stub and skeleton. Oh, we need to write that implementation of the stub and the implementation of the skeleton corresponding to our bank implementation. Okay. Now, if you look at it carefully, the job which they have to do is pretty monotonous. It's something which is mechanical. Fine. It's not something which depends on what kind of different logics, whatever, depending on what application you are writing. It's always a very similar job which they have to do. Right? Marshalling, unmarshalling, whatever parameters are there. Yeah, it's up to you to take care that the parameters which we have in our methods, in those remote methods, and they should be serializable. Fine, that care you will have to take. Fine, but fine, it doesn't have to do anything much. So what we have is we got utilities which can do the creation of stub and skeleton classes for us. Yeah. So the third step which you may probably use, because now it's not necessary. We'll see, now it's not necessary to do it. Right? From Java 7 onwards, yes, it's not necessary. The third step would be, right? You want to generate, so we have utilities to generate the stub, skeleton classes using command RMIC. So there's one utility called RMIC, which is part of the JDK, which can be used for generating the stub and the skeleton classes. So example would be, you might say RMIC. And what we need to give to RMIC? We need to give the compiled class. Oh, what I forgot. See, when we are writing those, defining the interface, defining the class in step 1 and step 2, we need to be compiling them. And so once we have compiled, we got the class file. Okay, and now what we do here is with RMIC, just give the class, implementation class, RMIC, and give the implementation class. So for example, RMIC, I might use bank IMPL. When it looks at bank IMPL, it loads that class file and would use reflection, fine, to find out what it is and generate what methods it should. Okay, fine. And it generates appropriate stub and skeleton classes. Oh, whether it generates stub and skeleton? Because yes, when it started, the RMI started in Java 1.1. Okay, it was introduced in 1.1. But there was one thing which happened in 1.2. In 1.2, they decided that, oh, instead of having two separate class files, one for stub and one for skeleton, we could merge in and have one class file only being generated, and let's call it as the stub. Okay, so we had, so when someone uses RMI C command, okay, you had the option of saying whether you would like to generate the two things separately, that is according to version 1.1, having a stub class and a skeleton class generated, or according to version 1.2, where we had only the stub being generated. So you could use the option and say minus v1.1, or you could say minus v1.2. So if you say minus v1.1, it will generate two class files, right? And what would be the two class files in this case? Well, the two class files would be named as bank impl underscore stub dot class and bank impl underscore scale dot class. So you'll get two class files if you use the option of minus v1.1. And if you use the option of minus v1.2, it would only generate the stub. And if I don't specify any of these, if I don't give this,
by default 1.2.
depends on your Java version. Till Java 1.4. Till Java 1.4, the default was minus v1.1. Okay. Till Java 1.4, if you don't specify minus v1.2, it would generate two classes. From Java 5 onwards, if you don't specify, the default is to use v1.2. Fine. So generating the stub and skeleton classes, and anyway, from Java 7 onward, it's not even necessary to do all this. Okay, it uses the dynamic class loading. Fine. In no, you have that dynamic classes being created, runtime classes. So that's the kind of feature which is being used from Java 7 onwards. Okay, and this step may not be necessary. Okay, so first part is fine. What we have been able to do is we have been able to generate the necessary class files. Right. Now, so it's something like this. Our type, the type which we have is nothing but the type what we have generated is a data type called bank. We call bank as a remote data type. But for this bank as a remote data type, bank.class is not the only thing which is needed. What is needed is the combination of bank.class, bank impl.class, plus if you got those stub and skeleton things created, those class files, these things combined together, that forms your remote type called bank. That forms a remote type called bank. Normally, most of the data types, just that single class file is good enough. But when we are talking about a remote type, oh, it's not one class file. The remote type would be that base thing, whatever is the interface name, that's your remote type. When I write my application, I'll use bank everywhere. Except for in a place where I have to create the remote object, I'll be using the constructor. At that place, we'll be using the name of the implementation class. Otherwise, everywhere as a data type, only use the interface name. Okay, we only use the interface name as a data type. Okay,
This stub class over here is
stub class.
stub class here.
I think so.
This stub class is like
Stub class is helper classes. Yes, helper.
means okay, but
It's like
we invoke from this stub class,
the
right?
stub is what implemented. It's also the stub is implementation of bank.
So whatever it generates automatically.
Yes, this is generated, but this is nothing but it is something which implements bank. What you will be having in the client side will be an object of this type. But yes, the type is still a bank only. It's an implementation of bank. So what you will be getting is a bank. But if someone says, what's a class? Get me the name of that object's class. You look at, oh, that's a stub object. You will find it like that. Right? Okay, now coming to this further requirements. Okay, so you develop the infrastructure, that's fine. Infrastructure is stub, skeleton, the implementation, we have the interface, development part is done. But now we need to write an application to use this. Fine. What will be the requirement? The server, or sorry, the remote object. We must have some virtual machine where the object has been created. Someone will have to write a code to create that object, create the object of bank IMPL. He's created the object of bank IMPL. But how is the client going to know that such and such object exists? How is the client going to be able to connect to that? There has to be some mechanism of being able to connect here. Some client just says, oh, I want to be able to, I know there is some object on that machine. And there has to be some mechanism, some service is necessary here. Okay, so what we have here is, yes, we got some TCP IP based service. Okay, so there is an additional service whose help has to be taken. Okay, it's known as a naming service. There is some naming service. As part of Java runtime, the name of the service, the utility which gives us this naming service is RMI registry. So RMI registry is nothing but simply a naming service. What it does, it can register some implementation object. Okay, what you can do is, oh, I have created this object and make it available. See, on this side, the on the remote, fine, on the server side, let's instead of remote, let's also start using the term as server. So on the server side, right, the object of remote object would be created, and this needs to be known through the service. So have it registered there. Give a name for identifying and be able to get information about the object. If the client wants, he should be able to inquire with the RMI registry, which is a TCP IP based service. RMI registry is nothing but simply a TCP IP based service which starts on port number 1099. So we have port number 1099 on which a RMI registry needs to be started on the machine where you have your remote object. Okay, it needs to be, RMI registry needs to be started. So at runtime, the necessary thing, yes, one is RMI registry. And once the RMI registry is running, what needs to be done on the machine, on this remote machine? The application here, yes, it would create the object and would bind, right? Would create a binding with the RMI registry. Fine. So there has to be this interaction with the naming service. Our RMI registry is a naming service, and there has to be some interaction by which it can interact and say, okay, this is where I would like to bind my object. And your application should be able to bind our remote object with the RMI registry. And our client here, okay, the client here should be able to say, oh, I want to get information about if you have such an object, so that I would like to be able to make connection with that skeleton and start my interaction. I would like to create the remote object. I would like to create the stub object and start the interaction. Okay, let's see this, how this happens. Okay, so what we have here is we got the additional thing is the naming service, right? Okay, and for naming service, let me take it here. Okay. For naming service, what we have is we have a class in the java.rmi package called naming. We have a class called naming, which has got static methods, and this is java.rmi package, and it has got only static methods which helps us to interact with that naming service. In this case, it's a RMI registry. Okay. So the naming class has methods. First one, which would be useful by the server side itself on the same machine. Okay. The RMI registry on the same machine. So a Java application would like to interact with the RMI registry on its own machine. Okay. And should be able to bind the object. Right. So we have the method. It has a method returns void. Name of the method is bind. Parameter is a string. It gives a name to a remote object. My remote object. When I say remote, our remote is nothing but the implementation object is already a remote, because it implements the interface which extends from remote. It's my remote object. Right? So what we do is, yes, for example, we'll say, okay, I have created an object of bank IMPL, and then I'll say, give some name and bind it. Right? So you are giving a name and doing a binding in the naming service. So by this, a registry is done. Okay. Information about this object is now available using this name in the RMI registry. It's a static method. These all the methods here in naming are static methods. So one method is bind. Then that application decides, no, let me unbind. So we have bind, we have unbind. When I say unbind, simply the name is sufficient to unbind. Okay, now one more thing about the bind is, if I use bind and give a name which has already been used, then the bind would fail. Oh, there are some other bindings which are already existing. Fine. I had started that application earlier, used a bind, and then I start an application. Still, I would like to replace that object. Right? If there is something already bound to this name, remove it. But I want my binding to go. This bind would fail if you use a name which is already in use. What we have is another method called rebind. You can straight away. So instead of using bind, you could actually be using rebind to say, okay, if it's not there, create a binding. But if the binding already exists with this name, replace. That's a rebind. Right? So with rebind, same thing as bind. And so these three methods are the methods which are interacting with the local naming service on the same machine, normally used by the server side. The one who creates a remote object uses these methods. Now the client. Okay. Now coming to the client part, the client would need to get the stuff. For that, he should know such and such object exists. He will have to interact with the RMI registry on a remote machine. Fine. RMI registry is on the remote machine. He should know what that remote machine is. Okay. So what he does is he uses a method. So on his local machine, he's using the static method. The method returns, it doesn't return void. This method return type is remote. Name of the method is lookup. Parameter to that is a string. This is nothing but your URL string. Oh, this URL string has a typical format which looks like this: RMI colon slash slash. Okay, and whatever is the host, right, because you want to interact using this method, you would like to interact with the other RMI registry. So that host where that whose RMI registry you would like, right? So that host is here. Fine. It may be in the form of IP address or a resolvable host name which can be resolved. Fine. And then of course you have the option of using colon and port number. Fine. If you don't specify, by default it will be considered as 1099. So optional part is you can use optionally colon and some port number, because RMI registry could have been started on a different port also. By default it is 1099. Okay. By default RMI registry starts on 1099. But when you start RMI registry, you might have given a different number. And you can start on a different port altogether. Right? In that case, this would be required. Right? Default would be 1099. And then slash, and what's the resource name?
URL or
Oh,
IP
the name by which the binding was done, that name can be introduced here. If you know that name, you can do a lookup and get that object. So that's your URL like. Okay. So for example, okay, see now what is normally done. Let me show the uh, small part of the code.
name means the remote machine's name.
The name used for binding the object. I'm looking for the object. I'm looking for that object. And I'll just show a small code segment to explain this. Right? So we have on the server, we have a code which looks like, okay, let me create a bank. Okay, equals new bank IMPL. Fine. You would have called the constructor. It's having the appropriate try catch or throws whatever is necessary, because there's a throws remote exception whenever we call the constructor of bank IMPL. Okay, fine. Assuming that. Okay, so you got the bank object, and then the next step, you might do naming dot rebind. Give a name. For example, someone says, let me use the name as HDFC, and that's my bank object. Okay, and then what's the next step? Oh, so that's it. It just does this. The server side creates the object and just binds it. Nothing more. His job is done. I have made my object available. Okay. Now the client. The client code. The client code simply goes for this. He says, fine, that's a code on the server. The client, the one who now any client who would like to use this and would like to invoke a method, right? What he does is he does this. He says bang equals cast as bank. Remote, fine. Return type is remote. So you need to cast as blank naming dot lookup. As a parameter to the lookup, RMI colon slash slash the host where your remote object is. That host, IP address or whatever. Okay, fine. Colon port number optional. I'm assuming it started on 1099 and if I'm not giving a port number slash the name by which that object has been bound.
How the client will know that this is the name of
Client must be knowing. Oh,
it is already
client doesn't know. Suppose the client doesn't know, but would like to inquire what all objects do you have? Fine. We have a requirement. The client wants to know what all objects do you have, or before I do a bind or a rebind, maybe I would like to inquire locally what all objects do we have, what are all the bindings you have, what all names have been used so far. For that, one more method we have in the naming class. So naming class has 5 static methods: bind, rebind, unbind, lookup to be used by the client, and a fifth one which both can use. It can be used locally to interact with the local RMI registry, or it can be used to interact with the remote RMI registry. So let's see that one. So we have this static method, one more static method for the naming class. Do I have space there? Okay. So that's just one more additional method. So method of naming. Okay. Method of naming still continued. Fine. Naming has one more method, a static method to return an array of string. Method name I think is list. Is it list? Takes as parameter a string. Okay. Now how this is to be used? I'll just show the usage. If I'm inquiring on the local machine, because I want to do a bind or a rebind, something like that. I just want to check out what all objects names have been used here. I'll use it like this. We'll say string array, okay, names equals naming dot list star. The parameter to be passed is a star. Okay, this is for local, and the one for remote is going to be like this. Okay, this is for local, and for remote, string array URLs equals naming dot list RMI colon slash slash host colon port if required slash star. The last thing is slash star. That one slash star. And what will this string array look like? The string array would have URLs, the valid URLs which can be used for a lookup. Straight away you get the URLs which can be used for a lookup. Yeah. That answers.
yeah.
Okay. I think we'll tomorrow we have a look at few more things. I think. Yeah, little bit. There's a little more to be covered, right? And then I'll also give some exercise tomorrow. So be ready for exercise now.